Hello everyone, welcome to a new scientific moment. Today is going to present Ilan Olkies, who is the leader of a RIF project of RIF Scheduler. And before starting, this is the scientific moment. It's a talk space that is for technical talks, and whoever wants to give a talk, you can contact us through any social media or through a research forum, or also you can contact us through the Slack channel. Um, so yes, okay. Today Ilan is presenting RIF Scheduler, that is a service for scheduling transaction, and the main motivation of this project is to build a reliable service that allows users to schedule RSK transactions that will be executed in the future by a third party. So welcome, Ilan.
Okay, hello. How are you? How
No,
are you doing? Okay, let's
fine.
get started. It was a nice introduction. Thanks, Julilen. He's my friend since 4 years or five ago. Um, so we've been coding together so long. Okay, so let's start. Today we are going to talk about the RIF scheduler. The RIF scheduler, as Juli mentioned, is a service for scheduling transactions. This means that you are going to say when you want the transaction to be executed, and that is in the future. I can say, I don't know, I want to send $10 to somebody, but in a week. So this service will allow to do this with any crypto token, and additional, uh, this will allow to interact with any smart contract in the future. So you could, for example, withdraw from a DAO or different things. You can, for example, execute oracles in the future. So this is all the thing that this service will allow, and we are going to talk a little bit about how it works. First, I'm going to show how it works. I'm going to show the application. We are going to schedule a transaction, and then we're going to get a little bit more technical. Uh, I'm going to show the architecture, then how the smart contracts are written, but not just that. I'm going to explain why is it important to use smart contracts in this model. And then we are going to talk about the things that are built on top of the smart contracts SDK, the service that will be executing these transactions. And then at the end, we are going to talk about future work that can be done in the project. So let's start. What is the RIF scheduler? This is the first question, how it works. So I'm going to show it right now. I'm going to share the presentation link so anybody can follow the links, use the service. This is live. So I'm going to share over there in the chat. And this is the RIF scheduler. Basically, this is the platform of the RIF scheduler. Basically, I can go into here and say, okay, I want to execute a transaction in 30 minutes, more or less. And then I will choose a third party. I'm going to explain a little bit about this later, but basically you here choose the service provider. You can choose any of the services and any of the plans that this service provider will enable. And uh, over here, I'm executing a smart contract. I have a smart contract that just increments whenever it is called. So I'm going to schedule the transaction. Okay, I have a name missing. And okay, confirm. Basically, what I'm doing now is locking. First, at the beginning, I purchased some plans. Over there, I locked some tokens. Then I told the service provider when I want my transaction to be executed. And if he executed at the given time, over here, like in 30 minutes, then he's going to receive the payment that is locked in the smart contract. So basically, that is the RIF Scheduler. I would like to make a moment for questions. So if you have any, please put them in the chat. Okay, let's move on. So this is the scheduler. We are going to wait a little bit, and then in 30 minutes, we are going to check it again to see if it's executed or not. And let's see a little bit how it works. So there were a lot of things happening. So first of all, I went into here. I can see a lot of information about the plans I bought, then about the executions I made. Then additionally, I can see the things I did in the past. I can also purchase plans over here. So there's a lot of functionality. This all is happening in the client side. So this is the first part of the architecture. So the idea is that the client interacts directly with the smart contract. What you are seeing here in the UI, for example, I can show a purchase. First, I have 330 RIF. So I'm going to purchase a plan. Let's put some more. It's too cheap. Okay, I confirm the transaction. Now, when it's confirmed, you are going to see that it decreases my balance. But the whole idea here is that all this payment that I did is sent directly from my client side into a smart contract, and this money that I sent is locked in the smart contract. Then the smart contract will enable the service provider that is maybe in another part of the I mean, it's not does not need any communication directly with the requester more than the smart contract. We'll just read this smart contract and see what are the requests that are being executed, requested, and then we'll run a service that will do this frequently. So, for example, he can check each 5 minutes when a transaction is pending to be executed, and when that transaction needs to be executed, I mean, he finds the moment where it needs to be executed, then he submits the transaction and he gets the payment. So that is the whole thing over here. Okay, over there they are asking for some real cases for this. For example, I can give the simplest one. Maybe, for example, for paying salaries, your this platform will also enable you to do chronological things. So, for example, you can pay each month the salary to your employees, and that you perform one transaction and then you leave it there into the future. Then maybe more complex use case could be the ticks in an Oracle. Maybe you need to incorporate some information that is frequent. So you could use this service and pay somebody to do this work for you. That are some of the real cases. I mean, then you can use it just to send a deferred transfer to another person. That is something that it's a common use case as is. I mean, you don't. It's also part of the use cases that were thought for this. Okay, so this is the architecture of our RIF scheduler, and the question is, why do we need smart contracts for this? So I'm going to jump a little bit into the idea of the model. So basically, the service provider can provide different plans. These plans have a window for the execution. I mean, the execution is not an exact moment, but the smart contract that the provider will write will tell the user what's that window. So it will tell, okay, I'm providing the service for executing a transaction within more or less 5 minutes. And he activates the plan, he puts the price for that plan, so he can say, okay, each of the executions will cost, I don't know, 50 RIF. And then additional, he will set the gas limit for the execution. So he will also tell the user how much he's going to execute. I mean, there are transactions that are too costly, so the price will be given by the amount of execution you are doing. And then the whole idea is that any user in the network can then purchase this plan and schedule a transaction. So when he schedules, he's going to say, okay, I want to execute it in 1 month. He's going to purchase that plan, lock the tokens into the contract, and submit the payload for that transaction. So I don't know. I would say in 1 year, I want to transfer 10 USD stable coins to Holy. And I will just forget about everything in that moment and just leave the transaction there. So then in some moment, the service provider will execute that transaction. So over here, you see the execution window, and basically in that moment in the future, this guy will execute it and get the payment. So that's the whole idea of the model. Questions as for now? Good. Okay, let's move on. So I put a dark background now, because this is the dark side of everything. Now I'm going to show a little bit of the smart contracts that are behind this, and that's the whole idea of the model. Then I will show a little bit how the SDK works and how the front end is connecting directly to a smart contract using the user's wallet. And then finally, we are going to investigate a little bit what is inside the service provider side. No, what does the service provider needs to do? Okay, they are telling me there are questions, but I don't know where are they. Sorry. Jeremy, are they cancelable? Yeah, they are. Okay. Okay. Sorry. Okay, these are the questions. No, I don't know if I missed any other. Okay. Okay, so let's move on now. Now I'm going to jump into the smart contract. That is the whole idea of the product. So what is the smart contract about? It will enforce the steps that we defined over here. So basically, there is a guy that can choose what plans he is going to provide, and then any other guy can purchase this plan and finally he will be able to query what's the status of his execution to see if it's executed or not. So let's do it. We have this horrible function that is the part where the service provider will execute the transaction. So I'm going like backwards. I'm going into this moment. So this is the part of the smart contract where the guy actually executes it. So first of all, we have, well, we collect the information of the thing we need to execute, and we have the window validation. So this, as I wrote over here, will force this guy to execute it at an exact moment, no? So he's going to basically compare what he has set in the plan to the timestamp of the guy that requested the transaction. If it's all good, then he does the thing. He calls the other contract. For example, it could be the RIF token contract, so it would tell that contract send $20 at 4 a.m. So finally, he gets paid over here. So then after that, he will also emit the final state of the execution for the requester to check it. But at the end, he will get the payment. So that's the whole idea. If he didn't do the thing in the given moment, he's never going to get the payment. So over here, you can see that he's getting paid with the plan, with the token he has chosen in the plan. So we are good as for now. Okay, let's go for scheduling. Basically, this is the moment where the guy will, over here, request something to be executed, no? So I'm going backwards, as I mentioned. Okay, over here, scheduling. Okay, so the idea is the following. First of all, we check, for example, that he has not requested something for the past. I cannot tell a service provider to, hey, execute me this yesterday. I mean, it's not possible. So the provider will never allow a request of this kind, you know? He makes different validations for the request, and then he charges the user. So he discounts one of the plan tickets he has purchased. No, for example, as you saw there in the platform, I bought 50 or 10 or 10,000. I don't know. I don't remember how much, but they were executions. So they are like tickets. You consume one for each of the executions, and finally, it will notify the service provider about a new execution. No, so over here we have that part. After the execution is submitted and everything is validated, he will tell the executor, hey, you have a new request, so he will put it in his calendar and see when to execute it. Then going one step before, we have the purchase. This one might look simpler. So here this is a part where, I mean, I didn't put the code, but in this part, he's given these tickets for the executions, and then he locks the tokens in the contract. So as you can see over here, he's transferring the tokens. The user is transferring the tokens from his account to the contract. So until the execution is given, the contract will keep those tokens. So that's the whole thing. So over there, then those tokens, the service provider we have developed some other actions. Maybe they are not the most important to show no, but for example, the developer can say, I'm not giving my service anymore, so the users can unlock all their tokens, or for example, the service provider can, for example, cancel a plan. So he can say, I'm not giving this plan anymore, but I'm still giving the service in other plans, no? So I guess you can see that over here too. I don't remember. Yeah, so here inactive, different services. So the whole thing is that you configure your service and you get it executed at that given time, no? For more complex users, you would also need to check what's the gas limit of the thing you're purchasing. So it's not the same to execute 30,000 transaction RIF transfers than executing only one. So if you put that to the service provider, he will be charged more. So he will limit his plan to a given amount of executions. No. So that's now we are going back to color. Now that is the part that is already built. I mean, it's deployed. So now then we are going to see what the service provider needs, but the service provider will deploy that contract and will start providing their service. That is not the maybe the part you are going to interact more if you're going to integrate these kind of solutions. No, so we have an SDK that simplifies all this. All the operations that you saw in the front end are packed inside an SDK. I left the link there for the presentation, so you can check the documentation for it. Basically, Ethers is one of the Web3 clients, most common ones. So we built an SDK that is compatible with that client. So basically, the idea is that you create the SDK and tell what's the service provider. And then, for example, you can purchase a plan using this SDK. So you approve the tokens, and then you do the purchase. Or you can also use it for scheduling a transaction. So I would tell him when to execute it, what's the plan, and just schedule it. So all that functionality that was written in the smart contract is available in a very higher level. I mean, this has validations. It has also a lot of things that are being controlled by the Web3 client. So, for example, big numbers to prevent overflows. So this is a much more secure way to operate with the SDK, and this can be added in any front end. So basically, this is compatible with MetaMask, with your Trezor, or any other wallet. So that's the whole idea. Not also build something that works, but that it's really secure. I mean, if you want to integrate this into your application, the things you don't need to take care of are a lot. So that's the whole idea of our SDK. Well, then you can query what's the state of an execution, different things. That's on the web side. So if you want to build your application, I don't know. This is our app that is using our SDK, but it's published on npm. I mean, you can download these are the ones that I just bought. Okay. No, you can download the dependency and start interacting with the smart contracts. So you can inject any of this functionality in your application. That's really cool. So, I mean, really cool feature for DeFi, for example. Just plug in your UI and little UX that allows the user to perform it in the future. I don't know. that could be very nice. Okay. Then we have on the service provider side, I mean, you can use it as a user. You are paying to somebody, so there is somebody that can make an income with this. That's the service provider. So basically, he's doing work. You are telling him when to execute something, so he goes to his calendar, put the, the notification, and then execute the transaction. But of course, it is not a human. We have developed a service to perform this daily algorithm, or I don't know, concurrently algorithm. You're always checking. You should be always checking and checking and checking to see if there are new transactions. So of course, a human cannot do this. So the other part is also built, and I'm going to show a little bit of it. And basically, there's a guide if you want to start running your service and start making some income. So you can go over here. I mean, there's a lot of information, but it's a pretty quick guide. You just deploy the smart contracts, get the service running, and that's it. Anybody can then interact with you via your smart contract. So, how it works? This service basically it looks also like the first timeline I have shown you. First, it will listen to this is a service that will be listening to what happens in the smart contract. So it will be connected live to this smart contract, and it will store in a database everything that is requested. So a user comes, let me go a little bit back. User comes over here, and at the end of performing his scheduling, he will notify the this service, no? And over here, he will get the notification and store it, and then he will run another part of the architecture that is a recurrent thing that will be running. I don't know. You can configure it, but you can put it every 5 minutes or 10 or 15. But it should be according to what you put in the window, so that you don't miss any of the transactions in that window. But this will each, I don't know, 5 minutes go to the database and get all the things that are not executed and should be in those 5 minutes. So it will go and advance over the time executing the thing. So what's the pipeline over here? There's a guy that picks all the information from there, then puts the exact time. So I mean, even if if this runs given the window, it will try to put the exact time for the transaction. So it will put a timer over there, and then finally it will execute it. So that's the whole thing. I will check if there are some questions. Okay, I don't see any. Good. So that's most of it. I mean, it was quick. That was the idea. I would like to hear some questions. Now we are going into what's the future work of this. I mean, this was a project of 3 months, so it's a quick glance. Now I'm going to see if the thing was executed. It should. Okay, successful. Great. So, can one scheduled task be made conditional on another? Okay, no, that's a good idea. That's a good idea. Maybe it can be inside this of the future work. It can be built on the consumer side, maybe not on the client side. So maybe your smart contract is prepared to receive scheduled transactions that should be chained. I don't know. that might work. Uh, I mean, this was built with the simplicity, it's kind of an MVP. So we chose a model over here. I'm not trying to explain what's the idea of the future work. So we chose a model to represent, but we could add over here execution too. I mean, make it dependent from the previous one. So our MVP just contains this model. Well, there is maybe some additional things like the service provider withdraws all his funds, or I don't know. But the idea is to see the future work, what we can do with this, because it's built pretty simple. You see, if you executes it, and if not, not, and the user can then retrieve their funds back and just that. But the first thing that comes to our minds is penalties. So if this guy does not do his job correctly, then he can be locking some funds in the contract to pay the user some more money. I don't know. If you were paying 5 RIF for an execution and it was not done, I will give you back 10. So then, before purchasing your plan, you're going to check if he's going to be able to pay your penalty or not. No, that's more or less the idea over there. Then maybe together with the chaining, this is another idea that came up, that is adding some hooks. So you can prepare your contract for scheduled transactions, and then you can build a model based on this model. I mean, now it will just call the other contract and just that, and the other contract could check that the sender of this call is the provider, but I mean, it cannot be abstract to any provider. So this can be implemented maybe in a hoax way or a different way, but the idea is to tell the guy who was the original sender in a way that is secure, no? And then, well, another idea for this is the registry of service providers. So you can have a trusted registry. Then on top of that, you can build algorithms to decide what is what is the best thing you can buy at the moment, or maybe who is the worst service provider. So then on top of that, you can build a really, really cool thing. So all this is open source. It's ready to be forked, and you can do whatever you want to with it. I will show the repos. I mean, we have done some nice work. So you have here the smart contracts. Then here you will find what the server is running. So there's a nice guide to run it pretty quick. SDK, you can download it from npm, and that's it. A quick glance to RIF Scheduler. I know it was fast, so I will let a lot of time for questions. Maybe you want me to show a particular part of the project. I can do it too. I mean, we are with some plenty time. Thanks, Juan. Juan is there putting an emoji. Juan was who deployed the first version of it. So nice, Juan. Okay. Thanks, Remoni. Thanks. Okay. If you want to find me somewhere, you can go to any of the social medias. This is my handle. Thanks, Juli, for the space, and thanks everybody for attending, doing questions. Then, if you want to know more, just contact me. I mean, I'm an open book, so you can just contact me, and we can get in touch. So thanks everybody, and see you the next time.
Yeah, okay. Thank you very much, Ilan. I was muted. I was talking before. Thank you very much. It was a really amazing talk. So we are glad that you are here. So yes, as Ilan says, see you next time. Bye bye.